Yeah, it'll do 360. Okay, so I need to look at my participants.
iPhone needs like, Apple needs to have like double charger slots, so you can charge it really fast. Because they decided to take like two jackets and charge.
Okay. Kind of weird. Okay, so get your books out. Go to section 1.7. What are you just sitting there for? You should already have it open. 1.7. Transformations. Remember, we're doing transformations? 71. That's the end of the chapter. We haven't quit. We haven't finished talking about the non-rigid transformations. Okay, so if you just take something and click on it and slide it around like that, lift it, make it go up or down or over, that's a rigid transformation because you're not changing the shape of the graph. That make sense? It's like taking a picture of you and just enlarging it. No, not really enlarging it, sorry, but it keeps the same shape and size, everything's the same. That's the translations and reflections are called rigid transformations. And then non-rigid transformations is what they're talking about on page 71. Was Candace, did she say whether her computer was working or not yet? Because she's not. You don't think she's. Does she live far away?
Yeah, she lives like.
Okay. Because I wanted to. Oh, wow. Yeah. Okay. Okay, so on your calculators, go to y equals, or to your graphing stuff, and graph this. F of x equals absolute value of x. And then do also like F2, F1 and F2, whatever you want to call them. Do 3 times the absolute value of x, and then also do 1/3 the absolute value, 1/3 of x. And see what that does. And see if you can tell which one is which. Who's got all 3 of them? Anybody? Okay, oh, pretty. Do you know which one's which? What you can do, like the middle one is obviously the square, the absolute value of x. Mm-hmm. If you go back to y equals and maybe go in front and make it bold, or either one of those, yeah, okay, that one, 3x is bold. Then you can tell which one it is. Don't make that one bold because then you won't be able to tell.
So we do it dotted.
Yeah. So that's the normal one. Oh, okay. So see, the bold one is the 3. Get them yet? What's going on?
So the bigger the number gets, yeah, I got it.
You got to map in the number in
Closer
tabs.
it's like this.
Mm-hmm. What?
It's that right. That's not, never mind. I got it.
Got it?
Yeah.
So like, it's like what? Like 1/3 is that big.
1/3 is that one.
And also shows you which one they are.
Yeah, and so when it's like just 1, like if it was a 1 in front of it instead of a 3, it would just be normal.
How do you do absolute value, James?
Yeah, how'd you get the absolute value? Is it in the catalog?
It's right there. Oh, okay. Great.
You know how to, yeah. And you know which one is which? So that's probably the 1/3 one there. Yeah, yeah. Okay, so Here we're not, remember when we wanted to raise it, we would add a constant. And if we wanted to lower it, we'd subtract a constant. And if we wanted to move it right or left, we'd add or subtract a constant to the x. Okay, well now we're multiplying a constant. And think about this, and you might want to try this on your calculator too. You know how y equals x is just this right here? And if you think about it, the absolute value is just you take this part down here and you put it up here. So it's basically that like that. Absolute value is like that. See the red one? Okay, and so what if I had y equals 3x plus 0? It would have a slope of 3, right? And so it would go up and be steeper. Ah, terrible. And so this one, it bent it out here and it went steeper. So whatever this number, the book talks about stretching it vertically. Does it look like that's been stretched vertically, I guess? To me, stretching vertically and horizontally doesn't help me. I can't really tell what would happen if you'd stretch it. I don't know, I get confused with it. And so the way I think about when you have something being multiplied is I think of it as slope, you know, like mx plus b is the m is the slope. And the bigger the number, the steeper it's going to be. And then the smaller the number, the flatter it's going to be. Okay. And so even though, like, try it with, what do you think it'll do to 3x squared? What do you think it'll do to the parabola if you put a 3 in front of the parabola? Like if you normally have something like this, what do you think it's going to look like? Fatter or skinnier? Skinnier? Yeah, so try that. Erase those and put in 3x squared and put in 3x squared. And put in 1/3 x squared. And see what do you get if it's like that. You can try it. I like the ones with the different colors. Is yours? Yeah, yours does that. You probably want to get rid of the square root ones. Yeah, okay, and so does it tell you which one's which? So the red one is the 3 times x squared? All right. And so even though a parabola doesn't technically have a slope because it's curved, you can still kind of think of the steepness of it. Not, if it's going to be a steeper curve, it's going to be a skinnier parabola. And the wider one would be a smaller number like that. Let's see here. Yeah, I don't like those checkpoints. Okay, so turn to page 72. And I'm going to have you start working on the exercises in class. And it's a weird group of numbers. So you need to write all this down, including the section number. Section 1.7. 1 through 4, all. 5 through 9, odd. How many of y'all have map pencils? Anybody have map pencils? Different color pens? Maybe. Okay, so on number 9, you're supposed to be graphing things on the same axis. And so if you want to show different colors on it, you can, even if you're using a pen. I think that'll make it easier to see what's going on there. Then I want 11 through 20 all, again. And then 21 through 29 odd. And then 47 through 51 odd. And we'll have time in class tomorrow to work on these and finish that success organizer if you haven't already turned that in. Question? I can leave that. If I push this, it'll quit following me around. I like it. See? It'll just show the board. Any questions on the success organizer? I see some of y'all have that out. Oh, let me make a copy for number 9, so you'll have some. You don't have to draw it again yourself. And yeah, I'm a count. Into the printer. I'll be right back. This is for number 9. It's got a bigger graph, although you might rather do it on graph paper. I don't know, because this doesn't have a grid. Oops, sorry. She's still not there. Okay. Yeah, we probably do need to. I did find something we better go over because you're going to see it on questions and it's a little weird notation. This is, I'm looking at example 5. It says f of x. Could you quit knocking the desk, please, James? Equals 2 minus x cubed. Then it tells you to compare the graphs. It says for a, g of x equaling to f of 2x. What does that mean? Can everybody looking up here? They want you to compare f of x and g of x, but they write it like this. So what do you think you're expected to do? Yeah, so I think this is f of x, right? But you're going to put, instead of x, you'll have 2x. And so g of x is going to be 2 minus and then 2x cubed. That make sense? Okay. What if it had shown this? G of x equals 2 f of x. What would g of x be then? 2 times 2x cubed, right? So that comes out to be what? You distribute 4 minus 2x cubed. And this comes out to be 2 minus, you have to just, distribute that, 8x cubed. So you're going to see some weird notation like that on certain problems. You have to understand what they're talking about. And you see the difference. Here they have the 2 in front of the whole function, and here they have the 2 just in front of the x. This is what really affects the slope. I don't know, though. Kind of depends on the function. So that's 1715. So you're going to finish that and turn it in for late grade at some point? Or that was the extra I gave you when you had already, yeah. Okay, I remember that. You need to get back to work, James. You need to get a paper and start working on stuff.
I'm trying to figure out how to do this real quick.
Hmm?
Trying to figure out how to do this real quick with the containers.
What are you doing real quick? You don't have a function for it.
I can go like, boop.
It's not gonna work. It has to be this function right here.
Oh, I see.
And have you done 1 through 4 and 5 through 8 yet?
Yes, I have. Yes, I have.
So not really. So what this means is you're going to take each of the x's. Like what I did was on these, I put all these numbers, those points down here on the table, right? Those are the 4 points. And so for A, you got to change the sign of the x coordinate. And so I went over here, I left all the y's the same, but I changed the signs of all the x coordinates. Now you got to plot those points, okay? And that would be what f of negative x is. And so you want to do a different color for each one. So you'll want 1, 2, 3, 4, 5, 6, 7 colors if you have them. I used to have colored pencils here, but I don't think I do anymore. Let me look over here. Okay. No, I don't see them. So if you have a different color inks, that would be good too. Okay, then B, you're going to add 4 to the y coordinate. Negative 4, negative 2, 0, 6. 6. Add 4, 2, 2, 6. So always refer back to your original right here for each step. That's what you do to each part. And you'll graph the new points when you get there. D. Uh-oh. No, I did something wrong with D. Let me see. X minus 1 to the sine. Oh, I see what I did. 2, 2, 4, 2. Did that. Oh, you have to add 4. Okay. That's what happens because you have negative after x minus 4. This changes the sign of y. But a negative and a negative. Two, 4, yeah. Question? Let's see what these are going to do. No, nothing wrong there. So x's are right. 4, negative 2, 0, 6. No. So this one you gotta switch these around. Change the sign first, then subtract 1. -2, 2 to -2, and then subtract 1. -2 to 2, and then subtract 1. Yeah, that's what happened. G. Coordinate by 2. That's 2, -2, -2, 2, -8, -12. Two, two. So no, I did something wrong again. Probably did the wrong one. The x coordinate by 2. Saying it's -1, 0. We're dividing by 2. What the heck? Okay, I think they have a typo there, but I'm going to check it out. Yeah, the answer in the book is wrong on G. What I said was first was the right, because they have it maybe by 1/2 instead of 2. So multiply it, that'd be -8 to 4, 0, 12. Oh, she's there now. Candace, isn't it? Hello, Candace, are you there? She's muted. Oh, there she is. Okay. I'm using a new technology. Can you hear me? Aha, now do you see me?
Yes, ma'am. I'm sorry about that. When I got
Can you
home,
unmute?
apparently. Oh. Hello?
So I'm using the swivel robot. And so I've just got you on the iPad facing the board. So watch what happens. Let me see, turn this back on. It'll follow me around when I move. Can you, yeah. So let me, now you can see. There's Brian. And Eddie is over here. She sees you. Okay. And we've been doing some of the problems from 1-7. These are the problems you need to write down. I don't think I have them in the Google Classroom yet. And I'm going to see if I can switch. Hang on a second more. No. Can you hear me? Yeah,
Yes,
okay,
ma'am.
good. Okay, grid. Aha, there that goes. Hoping I could pin mine up there. Okay. I'm gonna. Okay, now it'll stay. And she can see that assignment. Maybe. Can you read the writing in the black?
A little bit. It is very pixelated,
I can't hear you.
so I'm not.
I wonder if I don't have a speaker on this iPad. Try it now. Whoa, that was the wrong thing to do.
Can I stretch?
Yes. Which camera? Oh, no, I don't know if it says odd or all. Okay, that's a good point. Ooh, that was odd. 10-49. Okay.
Then what?
20.
Is that $20?
I wonder why I can't hear her. So you're not muted, right? Okay, so say something kind of loud. Like hello.
Hello?
Scream and loud. Candace, scream.
No, let's see what does it
We have
say.
to talk into that thing.
She sat. Oh, what did I do there? Oh, okay.
We have to talk into the necklace.
Yeah, I don't. I mean, I am, but I've got 2 more mics that I could put up if we really wanted to hear y'all. But guess what? Chat for a little bit. It was very pixelated, so I don't know if it's oh, pixelated. That's a bummer. At some point, I'm going to have it hooked up with my laptop. Right now, I don't. I'm just kind of seeing what I can do and not do.
Probably the school Wi-Fi that's doing this.
Yeah.
Yeah, but I don't know if that would pixelate it.
during history of media, everything was pixelated, so. Paper. Tree slabs. Tree slabs. Do you write any tree slabs?
Okay.
Do you write any tree slabs with your rock?
Is that better?
Do you write any tree slabs with your rock? What do you think your tree slabs are?
Let me see what the. We don't have any working printers at the moment. Oh, bummer.
Good tree slabs.
That is better. Good.
Clear tree slabs that line clear.
As far as the printer's concerned, let me see this. Here's the handout. So you could look at the handout on the screen and just write your answers on paper if you can't print it out. Would that be all right? Need help? Let me see what she is saying. I can't write. Did you email pictures of it? Oh yeah, because that's a good idea. I will do that. Okay. In just a minute. Yeah. I know, right?
Equal?
I bet they have a typo. I bet they meant to put something in between there. Like if they have a 3 here, you would say it would make it steeper by 3, you know. But yeah, in that case, there's no change because they.
So it's equal.
Yeah. Okay, and that's if I have a 1-7 that's blank. Has anybody not started their 1-7 yet? Probably not.
Just almost finished the front page.
Yeah, that's okay. I'll print it out again. Take a picture. No. Flash it. Well, taking this time. Wait, oh, that took forever. Need to be working. Yeah. Go throw it in the trash. And my phone is. There it is. Okay, we don't need to be distracting the class though, so just stay forward and do your work. Okay. All right. Mm. Okay. So Candace, I'm sending them to you, texting them to you, and I photographed half a page at a time so you could see it a little bit better, but let me know if you still can't see it very good. I think that's gonna look good. Okay. No tapping or kicking or making noises, James. Once you hold the pencil the other way, yeah, so you can write with it. And you have questions on anything?
I know how to do 5 and 7, but
Okay, let's look at 5. On 5, they're talking about,
or just plug them in.
no, this non-rigid transformation. And it says that if C is greater than 0, you have a vertical stretch. And then you have a vertical shrink when C is between 0 and 1. And so see, it says when C is greater than 1, that's this vertical stretch. And then this will be a vertical shrink. That's 3. Oh, you already had that one? Oh, you know you didn't have that one. 5, for each function sketched on the same.
For 5, do we plug in?
Sort of, yeah. You're plugging in number, you plug in -1 plus C here, and graph it, and then plug in 1 for C and graph it, and then plug in 3 for C and graph it on the same axis.
Okay.
And then do the same thing for that one.
Gotcha.
And it says on the same set of coordinate axes. Yeah, so do it all on the same, and not too small of an axis. Yeah, what can I get you? Oh, that's, yeah, it's that one down there, yep.
You know,
Yeah, good. I got my swivel up and I've been experimenting with it.
I bet we can think of some really cool things to do. It's motion following motion.
Yeah, I don't know, sounds hard.
Like if we attached a little armature to it, we could make it spin by moving, but make the armature move and do something else.
I could just, put a straw on it.
Yeah.
I could point at things.
Yeah.
Okay, now that is technically Uncle Steve's, although I've had it like 30 years or so. Yeah, and I don't know how it can, if it's very fragile or not. That's why I normally keep it away and packed up. But I didn't want to have it around for kids to mess with.
Yeah.
But if you're supervising, you're good.
I will.
Yeah. Have fun.
You're going to college after?
Yeah. Yeah. Back to work. Let me see if we got any more comments. Chat. And then the book due. When is the assignment due? Let me look. It's due on Friday. Candace. Yeah. And that was 317. That's good. Thank you. The book due. Good. Yeah. Okay. Okay. So, did you get 5 started? You switched over?
Yeah. We'll work on the other thing next. This is this folder.
Then which one is that? It's like a absolute value again. So what would you have to do to have a vertical shift of 3 units downward?
You'd have to have, it would be minus.
Would it be?
X equals quotation. X minus thing.
Well, you'd have the absolute value, and then would the -3 be in the absolute value or outside?
Outside?
Yeah, yeah. What about horizontal shift of 2 to the right?
It would be -2 inside.
Right, good job. Mm-hmm.
Six graphs.
Yeah, so
All in the same graph.
it's for each function. I guess these are different functions. So you can do these all on one graph and that all on one graph.
Okay.
I kind of like the idea of putting all 6 of them, but you can just do 3 on
That
each one.
sounds terrible.
Then it'll be all, yeah, okay.
I mean, I can.
Nah, it's all right. It says for each function, those are different functions, yeah. Again. Oh, wow, that's cool. And you're actually graphing those? You might want to pencil it in and then maybe, but it's up to you. How's it going? Oh, you can do different colors like that. You gonna do it with your pencil first and then, yeah, that's pretty cool. How are you doing? Okay, that's 5. Yeah, those are good. Did you just know what to do, or did you put it on your calculator and
No, I just
you knew that it had to
know what the absolute value
go
is.
up one or, yeah.
Plus,
Yeah.
or if it's not inside of that, it needs to be here. If
Right.
It's outside of it.
Well, good. And it's like you even kept your line at a 45-degree angle. Yeah, good job. How you doing on 7?
Sorry.
Okay.
Doesn't it feel like
It's gonna be very similar, but yeah, like you do the regular one and then you have to shift those little steps one way or the other. Yeah. Nice. You can see how the -1
Yeah, I'll do.
pulls it down. Uh-huh. Oh, cool. Okay, well, I see something, I don't know what that is, but
That's an A.
an A, so that was A.
Yes, ma'am.
So it'd be good if you could somehow like
back,
label
yeah.
all of them.
Yes, ma'am.
Think you can figure that out? Okay. Here it is. I'm gonna put it back. Let's see it.
Up and down.
Hmm?
Does the camera move up and down?
Mm-hmm. I want it to be able to get all of that.
I feel like go down like this.
Okay, that gets. I get pretty much most of it. Come in a little bit. Right there. Yeah. Now it should stay there. And it's hard to read. So Candace, I've got hello, on the board, tell me how hard that is to read. Is that impossible to read? Is it pretty pixelated? Oh, she's typing it. I can read it. Okay. So what I did there, just so you'll know what I did, is because it's all over the place. Let me show you. You got my mic here? Yeah. So I started here in the middle, and this is the original dots that were in that picture. There's a picture for number 9, and these were the 4 different dots that were on it. Can you hear me? Yeah. Oh, she's gonna type something. And I can read it. I'm not sure. Okay. And what you're supposed to do on number 9 is transform those 4 dots in A, B, C, D, E, F, G ways. So 6 different ways. And so I wrote down the process to use in the middle section here. For A, you would just take these X numbers and change the sign of just the X numbers. And so this was A right here, where these are the same, but these change the sign. And then B, you're supposed to add 4 to the Y coordinate. And so that's what I did there. So I've got the instructions written down here for all of them, and then I have the different sets of data all over the place, so it's kind of a mess. If you're having trouble with that, I'll redo it on another piece of paper and send you a picture. Okay. I think. Getting stuck anywhere? A lot of hard writing and sketching. How about you? Yeah.
Number 14.
Here's a graph. Okay, so the square root of x, that's where it starts in the origin and goes up like that. So this looks like the same thing, except it looks like it's been moved down, and it looks like it's been moved over 1, right? This way. And so inside the radical, you'd have x plus 1. But it's also been shifted down 7. And so after the square root, you'd write minus 7. You'd have the square root of x plus 1 and then minus 7.
Oh.
That kind of thing. This one's been flipped over, so you're going to have to negative and then also do the shifts.
Yes. Thank you.
Put your feet over there. Maybe you won't be tempted to be tapping on that because that's really annoying. All right. And don't tap on it there either. Maybe move it way over here. Good. We're not out till 2:20, so don't stop working. I don't know what's going on out there. Two, 0, 6.
listen to this one?
Okay, you probably need to go ahead and pack up so you can wipe your desk off. And we'll work on this in class tomorrow. And then it's all going to have to be turned in Friday at the beginning of class. I'm going to go ahead and end the recording, the streaming, and you can let me know. Wait, okay, let me look at, do you have any chat? Hang on, let me see. Ah, I thought, okay. Let's see, day, oh dear, number 4. Try to read the book, didn't help. First text for me. Okay, I'm reading your thingies. Okay, so I am going to send pictures of the board notes and I'm going to put them in a better fashion so it's more understandable. And we started on this yesterday and it's about transformations. I might send you links to some good videos on that and then see what you can, if it makes any sense, and then you can ask me questions. You already had chart A, B, C. Okay. Yeah, well, I'm on my new sheet of paper, I'm referring to the little equation they give you and why the chart looks like it does. So it'll hopefully help a little bit better. And then the first X on B is a -4, not -9. Yeah, okay. So, and if it takes you longer than Friday, that's fine. We'll keep working at it until we get it done. Okay. Okay, well, glad you had fun at the botanical gardens. It was good to see those pictures of y'all. Okay, well, I'll talk to you later. Bye-bye.